Hey guys, I had a little time on my hands and I was playing around with various Tinkerer boards, and one that caught my eye was the Rock64, which is supposed to do 4K video H.265. So I thought I would try one out and compare it to the Marvell chip that's in the frame and see how it does. Uh, Here's the board I bought. I bought the 4 gigabytes DRAM version. Price was about $45. I added 32 gigabytes of eMMC onto it. This doesn't come with Wi-Fi, so I had to buy a USB dongle, plug it into the USB 3.0 port. So all in, I think total cost was in the $80 range. You'll see that the Rock64 board has impressive specs all around compared to the Marvell, with maybe one exception, which is the hardware codec. So on the Marvell processor, we have a 32-bit quad-core A9 CPU running at 1.2 gigahertz. Comparing that with a 64-bit quad-core A53 CPU running at 1.5 gigahertz on the Rock64. So clearly the Rock64 has much beefier CPU processing power on it versus the Marvell Armada chip on the frame. What Marvell has going for it is it has its own built-in H.265 hardware decoder and encoder. In addition, it has post-processing, video post-processing in hardware. So all things video, it's accelerated versus the Rock64. However, the Rock64 makes up for it with an ARM Mali 450 MP4 GPU. So that's 4 processors. It handles 4K frame buffers. So for the most part, it does a pretty good job of hardware assist in decoding H.265. The downside of using a GPU versus a dedicated hardware decoder is that you have to tie all the phases together. So there's a little bit more memory pressure put on it. There's a little bit more CPU pressure put on it because you need all the glue logic that you don't need in the Marvell. It does seem as though the Rock64 does a really good job of H.265 30 frames per second decode. When you get into 60 frames a second decode, it doesn't do as good of a job. In theory, Marvell is supposed to handle 60 frames a second decode of H.265, but there are other bottlenecks that Marvell has which cause a problem. Now for the frame, we only encode at 30 frames per second. So decoding 30 frames a second isn't really the problem. Where you run into potential bottlenecks is video post-processing. That's after decode. So assuming you have enough horsepower for decode, then you have to deal with passing these large frame buffers around. And I think that's where Marvell has bottlenecks. Rock64 possibly does. But as far as memory goes, on the frame, there are 2 gigabytes of DDR3 memory, but only 1 gigabyte of that is actually visible. The other 1 gig is hidden, and it's used for the security processor. On the Rock64 board, there's 4 gigabytes on my board of DDR3, same speed, but it's a 64-bit processor. So it handles this more efficiently, and having more memory has advantages. So you can cache a lot more in memory than the Marvell. So I think Rock64 has an advantage there, clearly. Wi-Fi performance is interesting. I did some measurements a long time ago on the Marvell Azure Wave Wi-Fi module. It's potentially capable of higher throughput. However, the module is on an SDIO interface, which is in theory maximum bit rate of 100 megabits per second. I actually measured about 100 megabits per second with iPerf, which is raw throughput without writing to disk. However, with the frame, you have to download that, doing progressive downloads and write it to disk. And there I measured an actual throughput of 30 megabits per second, kind of max, assuming everything else is doing well. So that's about as good as we can do with the Marvell chip. I actually ported the frame firmware to the Rock64 board, and I'll show you that in a little bit. And I connected a Wi-Fi dongle to the USB 3 port, so it's not limited by the SDIO interface. And actually, writing to disk, the player doing progressive downloads, I'm getting roughly 90 megabits per second, and actually I see a little bit faster in some cases. So it's quite noticeable as far as writing videos, playing back of videos on the Rock64 board. As far as playback, I'll get to that. Playback is read on the frame. It's read from a USB thumb drive. I had to read from, for kind of a silly reason, I had to read from eMMC and use that as a place to cache the videos on the Rock64 board. It has to do with Android's limitations on how USB devices can be accessed, and I just didn't want to go through the extra work to make that work. So I think there is potential bottleneck there. Where I've been seeing various bottlenecks, I can definitely see that Rock64 on occasion seems to have problems with overall system performance, which I think is CPU power. Marvell clearly has enough CPU horsepower for doing video decode of a single H.265 stream. Where I think it's always had a problem has been in memory bandwidth. And I believe that because even 1080p videos, I see stuttering of 1080p videos. So that clearly is, it's 1080p 30, so that there should definitely be enough headroom for that. However, after video is decoded, you end up with these large 4K video frames. And if you have to do any copying, which Android requires without what's called tunneling mode, you end up doing a bunch of extra frame, well, a few extra frame buffer copies of 4K video frames. And I think it's tending to max out the total memory bandwidth. This is Marvell's M player, showing that even their player jitters. So they have some performance bottleneck, which I believe is memory bandwidth for their DDR3 800 megahertz. This is again showing Marvell's MR player. You can see the stuttering. Here's the Rock64 board in action. It's got HDMI out, power, USB 3.0. There's a Wi-Fi dongle for Wi-Fi. This is USB 2, and it's just basically powering this fan because this thing gets really hot. So this is my test system. I should also mention that here I'm running Android 7.1, ExoPlayer 2, so it's upgraded from what's on the Marvell, the frame, but it's ported
the frame firmware with some tweaks so it'll run on this platform.
This is a video that's been very problematic on the frame because of the slow panning. You can see stuttering very well on the Rock64. This is a Rock64. It's been very smooth. This one's always been very difficult on the frame. It's been really bad at stuttering. And on the Rock64 doesn't seem to be stuttering at all. This is one that's never been smooth on the frame. It actually looks great. Just to give an idea of what this is an LG OLED display. It's hard to tell, but the blacks are just amazing on this screen. One problem I did notice on this startup is very jittery for the first number of seconds, and then it straightens itself out. That may be because I'm using eMMC as cache, and it takes a while to pre-buffer, and until the buffers are full, it's going to starve itself and struggle. The other problem may be that ExoPlayer itself is not doing a good job of pre-buffering, so I haven't looked into it any further. This is a new port of ExoPlayer. So, what do I think overall? I think this platform does quite well. For the most part, it does much better than the Marvell chip. The main problem with this is it only has HDMI out, so to interface with any panels is kind of a clunky HDMI to V/1 adapter, which adds quite a bit to the cost if you needed to go that route. The other option would be to there's a Rock Pro 64 chip, which is beefier, which has EDP display output, EDP 1.3, which is supposed to be able to handle 4K display or UHD display. But EDP tends to be used with smaller displays, like for laptop displays. I don't know of any larger screen panels which use EDP, which take EDP as input, but I haven't looked into it too deeply. There are a couple other cheaper solutions similar to this one that have EDP display output, so that might be an option. Anyway, overall, I'm quite impressed with this board.